The electrical code addresses requirements for pull and junction boxes, specifically concerning their dimensions, length, and width. However, regarding minimum volume requirements, the code's focus shifts depending on the conductor size. Section 314.16 of the code primarily addresses the volume requirements for boxes enclosing conductors of size #6 and smaller. The volume calculations within 314.16 are rooted in two key factors: the number of conductors present within the box and the size of those conductors. The intention is to ensure adequate space for heat dissipation and to prevent overcrowding, which could potentially damage insulation or create unsafe conditions. To determine the minimum box volume required for conductors #6 and smaller, one must consider the following elements. Firstly, count the total number of conductors that will be housed within the box. This includes all conductors, both those that are spliced or terminated within the box and those that pass through without being spliced or terminated. Secondly, identify the size of the largest conductor within the box. The required volume is influenced by the conductor size, with larger conductors requiring more space. Thirdly, consult the tables provided in 314.16 or the relevant tables referenced within the code. These tables specify the minimum volume required per conductor based on the conductor size and the type of box. Fourthly, if the box contains devices such as switches, receptacles, or equipment grounding conductors, additional volume allowances must be made. These allowances are also specified in 314.16. Fifthly, calculate the total required volume by summing the individual volume requirements for all conductors and devices within the box. This total required volume must not exceed the maximum volume of the box. The minimum volume requirement ensures there is sufficient space for proper wire bending, heat dissipation, and safe installation. However, for pull and junction boxes housing conductors larger than #6, the approach to determining the required size differs significantly. For conductors larger than #6, section 314.28 comes into play, focusing on the dimensions of the pull or junction box rather than a specific volume calculation. 314.28 outlines requirements for the length and width of the box, based on the size and number of raceways entering and exiting the box, as well as the angle of the pull. The intent here is to ensure adequate working space for pulling conductors through the box without damaging them or placing excessive strain on the connections. To determine the minimum dimensions of a pull or junction box for conductors larger than #6, several factors need to be considered. 1. Determine the trade size of the largest raceway entering or exiting the box. This information is crucial for calculating the minimum dimensions. 2. Identify the number and arrangement of raceways entering and exiting the box. The code provides different requirements for straight pulls, angle pulls, and U-pulls. 3. For straight pulls, where the raceways enter and exit the box on opposite walls, the minimum length of the box must be at least 8 times the trade diameter of the largest raceway. 4. For angle pulls and U-pulls, where the raceways enter and exit the box on the same wall or at an angle, the minimum distance between each raceway entry inside the box and the opposite wall must be at least 6 times the trade diameter of the largest raceway. Additionally, the distance between raceway entries must be at least 6 times the trade diameter of the largest raceway. 5. If the pull box contains splices or terminations, additional space may be required to accommodate the splices and ensure they can be properly installed and maintained. 6. It is important to select a pull or junction box that is large enough to accommodate all of the conductors, splices, and terminations without overcrowding. Overcrowding can lead to overheating, insulation damage, and difficulty in making connections. There are some key differences to keep in mind when dealing with conductors of different sizes. Firstly, for conductors #6 and smaller, 314.16 provides specific volume requirements based on the number and size of conductors. Secondly, for conductors larger than #6, 314.28 focuses on the dimensions of the pull box, ensuring adequate space for pulling conductors. Thirdly, the calculations and requirements for conductors #6 and smaller are primarily based on volume, while those for larger conductors are based on linear dimensions. Fourthly, the code emphasizes conductor fill for smaller conductors, ensuring the box is not overfilled, while for larger conductors, the focus is on providing sufficient working space for pulling conductors. When working with pull and junction boxes, it is essential to adhere to all applicable requirements of the electrical code. This includes not only the requirements for box size and volume, but also those for box construction, installation, and grounding. Failure to comply with these requirements can result in unsafe conditions, equipment damage, and code violations. Here are some additional considerations for selecting and installing pull and junction boxes. Firstly, choose a box that is appropriate for the environment in which it will be installed. For example, if the box will be exposed to moisture or corrosive substances, select a box that is rated for wet or corrosive locations. Secondly, ensure that the box is properly supported and secured. The code specifies requirements for supporting boxes, depending on their size and weight. Thirdly, use appropriate fittings and connectors to connect the raceways to the box. These fittings should be listed for the intended use and should provide a secure and watertight connection. Fourthly, ground the box in accordance with the requirements of the electrical code. Grounding helps to prevent electrical shock and provides a path for fault current to flow back to the source. Fifthly, when installing conductors in the box, be careful not to damage the insulation. Damaged insulation can lead to short circuits and ground faults. Sixthly, label the box to indicate its purpose and the circuits it serves. This can help to prevent confusion and make it easier to troubleshoot problems in the future. Seventhly, always consult the latest edition of the electrical code for the most up-to-date requirements. The electrical codes are subject to change, and it is important to stay informed of the latest regulations. Eighthly, consider using a larger box than the minimum required size. A larger box can provide more working space and make it easier to install and maintain the wiring. Ninthly, use wire connectors that are appropriate for the size and type of conductors being used. Improper connectors can lead to loose connections and overheating. Tenthly, ensure that all splices and terminations are properly made and insulated. Poorly made splices can create a fire hazard. The selection and installation of pull and junction boxes are critical aspects of electrical work. By understanding the relevant code requirements and following best practices, electricians can ensure that electrical systems are safe, reliable, and compliant with all applicable regulations. Remember that the electrical code is a complex document, and it is essential to consult the relevant sections carefully before beginning any electrical work. If you are unsure about any aspect of the code, it is always best to consult with a qualified electrical inspector or engineer. Proper box sizing and installation are essential for safety and code compliance. Always refer to the most recent edition of the electrical code for specific requirements and consult with a qualified electrician if you have any questions. Understanding these distinctions and applying the appropriate code sections is crucial for safe and compliant electrical installations. Always consult the latest version of the electrical code and seek guidance from qualified professionals when in doubt. Conductor fill calculations and box sizing are critical for electrical safety and performance. Overfilled boxes can lead to overheating, insulation damage, and potential fire hazards. Ensuring adequate space within electrical boxes also simplifies maintenance and troubleshooting. When determining box fill, all conductors within the box must be considered, including equipment grounding conductors and neutral conductors, even if they are not actively used. Each conductor contributes to the overall fill calculation, and the code provides specific methods for accounting for these conductors. In addition to conductors, any devices mounted within the box, such as switches, receptacles, or lighting control modules, also contribute to the box fill calculation. The code assigns a specific volume allowance for each type of device, and these allowances must be included in the total calculation. The type of conductors used also affects the box fill calculation. For example, conductors with thicker insulation require more space than conductors with thinner insulation. The code provides different volume allowances for different types of conductors, and it is important to use the correct values when performing the calculation. The shape of the box can also affect the usable volume. For example, A square box typically has more usable volume than a round box of the same size. The code provides guidance on how to account for the shape of the box when performing the box fill calculation. The materials used to construct the box can also affect its ability to dissipate heat. For example, metal boxes typically dissipate heat better than plastic boxes. The code may require the use of metal boxes in certain applications where heat dissipation is a concern. The location of the box can also affect its temperature. For example, boxes located in direct sunlight or near heat sources may experience higher temperatures. The code may require the use of larger boxes or other measures to address heat buildup in these locations. The ambient temperature of the surrounding environment can also affect the temperature of the box. The code provides guidance on how to account for ambient temperature when selecting the appropriate box size and type. The type of equipment connected to the box can also affect its temperature. For example, equipment that draws a lot of current can generate a significant amount of heat. The code may require the use of larger boxes or other measures to address heat buildup in these situations. The number of circuits passing through the box can also affect its temperature. Each circuit contributes to the overall heat load, and the code provides guidance on how to account for multiple circuits when selecting the appropriate box size and type. The presence of insulation around the box can also affect its temperature. Insulation can trap heat and prevent it from dissipating, which can lead to overheating. The code may require the use of non-insulated boxes in certain applications where heat dissipation is a concern. Proper box fill calculations are essential for ensuring the safety and reliability of electrical systems. By carefully considering all of the factors that affect box fill, electricians can select the appropriate box size and type for each application and prevent overheating, insulation damage, and potential fire hazards. Always consult the latest version of the electrical code and seek guidance from qualified professionals when in doubt. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer before making any decisions about electrical installations. They can assess your specific needs and ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations. In addition to the topics already discussed, there are a few other important considerations when working with pull and junction boxes. One important consideration is the type of wiring method being used. Different wiring methods such as conduit, cable, and wireway have different requirements for box fill and support. The code provides specific guidance for each wiring method, and it is important to follow these guidelines to ensure a safe and compliant installation. Another important consideration is the type of environment in which the box will be installed. Boxes installed in wet or damp locations must be listed for wet locations and must be installed in a way that prevents water from entering the box. Boxes installed in hazardous locations must be listed for hazardous locations and must be installed in accordance with the requirements of the code for that specific type of hazardous location. The code also provides requirements for the support and securing of boxes. Boxes must be supported in a way that prevents them from moving or shifting, and they must be secured to a structural member of the building. The type of support required depends on the size and weight of the box, as well as the type of wiring method being used. In addition to the code requirements, there are also several best practices that should be followed when working with pull and junction boxes. One best practice is to use a box that is large enough to accommodate all of the conductors, devices, and wiring accessories without overcrowding. Overcrowding can make it difficult to install and maintain the wiring, and it can also increase the risk of overheating. Another best practice is to use wire connectors that are appropriate for the size and type of conductors being used. Improper connectors can lead to loose connections, overheating, and potential fire hazards. Another best practice is to label all of the conductors and devices in the box. Labeling makes it easier to identify the different circuits and components, which can be helpful when troubleshooting problems. Another best practice is to keep the box clean and free of debris. Debris can accumulate in the box and create a fire hazard or interfere with the operation of the electrical system. The use of properly sized and installed pull and junction boxes is essential for electrical safety. Following code requirements and best practices ensures a safe and reliable electrical system.